Good morning, students. Today we will start with a new chapter, that is polymer. It is quite interesting chapter and very much correlated with our day-to-day life. For example, in our daily life we commonly use polythenes, electrical switches, buckets, etc. These all things are made up of polymer. So in this chapter, our main focus is to study about what type of polymers are there, how they are prepared, and what and where they are used. So the word polymer is coined from two Greek words, as you see, poly plus mer. Poly means many and mer means unit. So we can say combination or condensation of large number of simple repeating units giving rise to a big size molecule is known as polymer, and this process is known as polymerization. Students, when we combine or condense these small number of large number of units, then we will obtain polymer, and this process is known as polymerization. For example, polythene. As the name indicates, poly plus ethene, means large number of ethene units will combine to give this polymer, that is polythene. So now we will discuss the representation of a polymer. In this polythene, repeating unit is this ethene molecule. This large number of ethyl we will combine and we will get our polythene. For example, we took large number of ethene units over here, and so as to combine these ethene molecule, we will shift this double bond to this carbon, and to satisfy the valency of this carbon, this double bond will automatically move towards, and in this way the chain will continues and we will get this type of structure which is known as our polythene. This structure can be simply depicted as CH2CH2N, where this N depicts that this unit, specifically this unit, is repeating large number of times. So students, if question arises define polymer, then we can easily define that polymer are very high molecular mass substances which consist large number of repeating structural units, and these units are joined through basically covalent bond. Here comes a very important point, that what are the monomers? Students, as you see, in order to make this polythene, we are repeatedly using this unit. Specifically, the repeating unit is known as the monomer. So we can define the simple and reactive molecule from which the repeating structural units are derived are known as monomer. For example, in polythene, this ethene is our monomer, because by using this unit again, repeating again and again, we are getting our polymer, that is polythene. Define polymerization. The whole process by which the polymer is obtained is known as the process, that is polymerization. Now, very important note that all polymers are macromolecules, but all macromolecules are not polymers. Macromolecule means those molecules which are macro. Macro means big in size. So how we can explain this? That is, because a polymer always consists of large number, basically 1000 number of repeating structural unit. For a polymer, this is the condition, that it should comprise 1000 number of repeating structural unit. But a macromolecule may or may not contain the repeating structural unit. Student, as you see, this also comprise large number of units, so the mass of this molecule will be very huge. It is also a big molecule, and macromolecule is also a big molecule, but the basic difference is it will always comprise 1000 number of repeating unit, but a macromolecule can have or cannot have the repeating structural unit. Now we will discuss the types of polymerization. Polymerization may be of two types, that is addition polymerization or condensation polymerization. Let's start with the first one, that is addition polymerization. As the name indicates, in addition polymerization, the repeating units will simply add or combine and give rise to a long chain polymer. For example, we took the ethene molecule, we took two ethene molecules basically, and these two ethene molecules are simply adding, and this comes under the category of addition polymerization. But in condensation polymerization, repeating units will also combine. But the twist is that when the repeating unit will be combined, then there will be a loss or elimination of small molecule, and that small molecule can be like water or HCl, etc. For example, if we consider a polymer nylon 6,6, students, you have to learn the monomer of this polymer. The monomers are adipic acid and hexamethylene diamine. Their structures are, this is our adipic acid which comprises 6 carbon, 4 over here and 1, that is total 6 carbon. And this is our hexamethylene diamine. These are the monomer, mane these are the repeating units. We will continuously repeat these two molecules and we will obtain the nylon 6,6. Now when these two units will combine, obviously they will combine by the loss of a water molecule. How? This OH and one H from here, one water molecule will be removed. So what we will get? We are getting HO, C double bond O, CH2, 4 molecules, C double bond O. This OH and H is removed, so this NH is joined with this C double bond O, and we are getting this dimer. In order to continue this chain, we will put one molecule of hexamethylene diamine over here and one molecule of adipic acid over here. So one H and OH will removed over here. Similarly, one H and OH will removed, and we will continue this chain and we will obtain the polymer, that is the nylon 6,6. Thank you.